today's video is all about misleading graphs. Now looking at this, you can probably think, yeah, the more time I spend in lockdown, the more YouTube subscribers I'm going to get, because doing pretty well. But however, this is pretty misleading, because if we zoom in, you might think, yeah, I'm going to get 1 million subscribers. But look at this fine print here. Must be divided by 100,000, meaning if I make it all the way here, if I go along my graph all the way up here, and then I go all the way into my graph, if I divide it by 100,000, I actually only get 10 subscribers. So, pretty misleading. And that's what we're going to be looking at today. So here's a cool real life example. The missing baseline, and that's what we'll be looking at. Times leaves the rest behind, or does it? Well, we've got some data here saying, well, the prices of the Times is 485,720, and the data graph only sells 446,000. The graph makes it look like the Times sells almost double, but in fact they are missing the whole bottom of the baseline. So it's very, very misleading. And that's what we're looking at. You have to take a closer look. And in fact, it's only really about 10% more. But, it cuts away the whole bottom. And it makes it so misleading. It makes you think that's where it starts. And it makes you think it's more than double. Again, you can pause the video here and give that a more detailed look. But yeah, very misleading. Another example you might have two rival companies, Company A and Company B, both sell headphones. Now, the data suggests that 1 in 10,000 headphones will break after 6 months, and that's only 0.01%. And now, Company A has a rival Company B. Now, Company A tests their product and 2 in 10,000 break. Again, very small percentage, 0.02%. However, if you look at this, that is double what's going on here. And there's no reason that Company A can't release a headline saying Company B headphones are 100% more likely to break after 6 months versus Company B. Again, it's true. It is true, but it's very, very misleading. Again, companies do that all the time. They manipulate data. They show you what they want you to see or don't to make you either sell something, buy something, or maybe not buy a rival company. And again, you see that. Keep an eye out on the news. You see that everywhere. So let's look at some questions. So we've got two graphs. They are the same. But this one here, honestly, someone's just gone on a different filter to make it look pretty. Again, it's very difficult to read. It's very misleading. We don't know what's going on here. That could be on Friday. It could be on Saturday. It's just very confusing. That's hard to read. It's nearly blocked off. That one's nearly blocked off. Very difficult. So we're going to focus on the one on the left. So this is showing Marco's text messages. On what day did Marco send the most texts? So we just need to see, well, text is sent in blue. Where's it highest? It's highest on the Saturday. So the answer here is Saturday. Over the whole week, did Marco send or receive more text messages? That's a go. Apologies, my Saturdays should go here. So the next question. How many more text messages did Marco receive than send on Tuesday? So on Tuesday, it's here. How many more text messages did he receive? Well, he received in orange 8, and he sent 6. So he received 2 more than he sent. So 2 more received than sent. Okay, over the whole week, did Marco send or receive more text messages? That's for you to answer. Add them all up and find me the difference. And you've got to see that in the Google form. You're going to do a Google form throughout this lesson. Okay. Right, what's going on here? All kinds of crazy going on. Right. Students were asked to choose their favourite desserts. Cool. Yeah, you want to know? I quite like a brownie. The pie chart shows the results. Okay. Why 3 ways in which the pie chart is misleading? Well, firstly, why is 34% bigger? Why is it bigger than everything else? It really makes no sense. Okay. Again, so why is it bigger? There we are. There's no title. No title. So that's just confusing. What's it showing? No labels. Again, what does what mean? Is 34%? Is that cake? Is it 75%? Is that Kit Kat? We don't know what's going on. Also, why is 75%? It looks bigger than the 89%. Okay, that makes no sense. And also, if you add them all up, a pie chart traditionally should all add to 100%. Well, we've got 75 plus 7 plus 27 plus 34 plus 89 all adds up to 232%. Again, don't really know what's going on. Really quite odd. It's very misleading. So on the Google form, give me a few more other examples and see what you can find. Right. Okay. So the cost of 1 gigabyte of data storage is shown on the graph. So naturally, as technology has advanced, it's become a lot cheaper. Keep an eye on the x-axis. Normally, x-axis would go up by a constant amount. Not doing that here. It goes up 1, 10, 100, 1,000, 10,000, 100,000, 1 million. Interesting. It looks to me every time it goes up by 10. Interesting that. Again, very misleading because it almost like compresses the data in. It makes it all fit on the graph, but again, it doesn't actually show just how rapidly the price decreases. It does rapidly decrease. So yeah, interesting that one. Okay. Question B, you've got to choose one of your book and submit it to Google Classroom. I've already showed you how I want it actually to look. Can you do me the year on the bottom? And I want you to go up in 2000s. I've already started you off here. So then you've got to get 60,000, 80,000, and so on. And I'm probably going to want 12 squares for this. Yep, I said here, go up in 12 squares for height. And I want you to plot this data here for me. And then I want you to submit a photo and show it to me. And then on the Google form, describe the trend of the price data stores from 1980 to 2000. And again, what graph shows it more accurately? So get that drawn in, and then show me the data. Okay, question 4. We've got 2 graphs on the same figures for Denise's clothing store. So, but look at the x-axis. This is what's so fascinating. This one goes from 10,000 all the way up to 11,000. So we've got all this data between 10 and 11,000, and we can see it really accurately here. It slightly dips, probably by £25, nothing major, and then it increases quite well, and we can see that really clearly. And here it's all sort of the same data. It's kind of squeezed in between here. Really difficult. We can barely see that £25 dip that we were describing here and here. We can see it here, but it's barely visible here. Okay, so we have some questions to answer on that one. And then question 4, I'm going to show you this. How can you show a percentage increase? Well, the formulas here is actual increase over the original amount times 100. So let me show an example. Original price is £50. So we're going to put the original price on the bottom. The increase is 10. That goes on the top. And then we're going to do 10 divided by 50. And then you're going to times it by 100. And that equals an increase of 20%. and I'll put every hour for increase. Here's another example. Well, the original price was £75 and the increase is 25, times that by 100, and you're going to get an increase of 33.33% recurring. Here we are. Last one. Okay, so the original price of 80, and it goes, the new price is 200, so that's going to show an increase of 120 over our original price of 80, times that by 100. On your calculator, that's going to be an increase of 150%. Like so. So, on your Google form, you're going to have 3 questions to do. And then let me show you one more example. What's the increase from 2010 to 2012? Well, 2010, we can see, I'm going to say a price of 10,125, which I've written here. 2012, so it's a price of, I'm going to say, sorry, go along to my graph, there we are, 10,600, 10,600, sorry. So I can see that's an increase of £475. So what's the percentage increase from 2010 to 2012? Well, the actual increase, which is here, our original amount is 10,125 here. On your calculator, 475 divided by 10,125 times by 100 gives you an answer to 2 decimal places of 4.69%. So do that in your calculator and just double check it. And then on your Google form, you have another question. And then lastly, I want you to think, I want you to explore this, chat to your parents, look at the newspapers, watch the news. How can you draw a line graph to disguise fallen sales figures? Again, let me just flip all the way back here. Look what they did here. You can barely see an increase. Can you do something similar to disguise poor data? Let's say you do real bad sales and you don't want to show your manager. How can you disguise those figures? Have a think. And I want you to do a very rough drawing for me and show me an example. So maybe you've got summer sales or winter sales and ice cream sales, and you know that obviously ice cream sales do really well in summer when it's hot and less in the winter because it's cold. How can you show that? And I want you to think, maybe give me a small paragraph. Is it easier to explore this question now that we've completed this lesson? And then what further information do you need to be able to answer this? And then last but not least, I want you to give me 5 ways. I want you to reflect on this as well. Give me 5 ways in which graphs can mislead you. For example, it is misleading when the scale doesn't go up by a constant amount. And why might a newspaper use misleading graphs? Have a think about that. Again, a great question to speak to your parents about, because they would have seen plenty of examples in their lifetime. Why would they? For example, one newspaper, might want to promote Nike over Adidas because they get sponsored by them. That's one way they might want to do it. Again, reflect on it and give me some examples. Better yet, can you find me a real life example? Have a read through today's newspaper. Great, well that's today's lesson. As always, any questions, I'm here to help. And I'll see you next lesson.